Okay, so here in section 9.3, we're going to talk about two sample proportions. So again, as you read through this, you want to look for those keywords proportions or typically percentages, and we're going to go ahead and run our 4-step hypothesis on this. Okay, so if you want to take a minute to read through this, go ahead and pause the video. Okay, so we see here are the proportions, and then they're talking about two samples, so medication A and medication B. So that's going to be a giveaway that we're doing two samples here. So two sample proportion. And so let's go ahead and get into our first step, which is going to be the null and the alternative hypothesis. So let's identify those. So the null and alt here. And we're talking proportions, so I'll go ahead and put a P there. And remember, we're comparing these to each other, so we're going to have proportion A and proportion B. You could use 1 and 2. I typically like using letters as a subscript. And so our claim here is we're saying that there is no difference. So no difference, that's going to mean that it is actually equals to. And so that's going to be our claim. By default, the alternative is going to get not equals to. Okay, our second step, let's get all of our data and statistics going here. And so we're going to want to find the number of successes, your sample size, and then, of course, the proportion here, the sample proportion. And notice I'm putting a subscript of A. That's to denote the medication A group. And then we're going to do the same thing with B in this case here. And so let's see. They're telling us how many we have. So 20 out of 200. And so that's given to us right here. And to get that proportion, we're just going to divide there. And then we're going to have 12 out of the 200 there. And the samples don't necessarily need to be the same size. This time around they are, but that's not always the case there. Okay, so we have these. And then let's see. Our third step, let's go ahead and move on and let's put our graph and our calculations here. And let's kind of start to piece all of this together. And we're talking difference in proportions here. We're comparing them to each other. So we're going to go ahead and subtract these out, similar to how we did the means, the difference with means as well. So right in the middle is going to be 0. Because if things are the same, that means the difference is 0 between them. And we could also talk about these in terms of z-scores. And this is going to be a two-tailed test, because the alternative says not equals to. And so I'm going to denote that as alpha half in this case. And as usual, we're going to want to figure out our z-critical values, our alpha, our z-test statistic, and then the p-value. And my alpha is actually 0.01, and that's given there in the last sentence. And my alpha, if I divide it by 2, I'm going to get 0.005. Okay. And so our difference here, if we're looking at kind of that horizontal axis, remember, we're trying to find out the difference between these two proportions here. And that difference is going to be 0.04. And so what we want is we want to get a test statistic for this guy. So we're going to actually convert this guy into a z-test statistic. So that's really what we're trying to figure out here. And we draw the arrow this way. So we're really trying to get a z-test statistic. So we're going to convert that using our z-score formula. It's a little bit longer since we have two proportions here. But we're going to go ahead and just plug this into our calculator. And that's going to spit out your test statistic and our p-value. And so let's go ahead and write that in here. So my test statistic is positive, so I know I'm to the right over here. And where exactly am I going to mark it at? Well, if we compare my p-value with alpha, your p-value is going to be larger than alpha. So you could either compare these two values here, or technically, if you're looking at the graph, you should be comparing half of the alpha and then technically half of your p-value. But either way, it's going to be the same. You're still going to figure out which one's larger. So our p-value has more area, so that the significance or the critical region should be contained within there. And so let me go ahead and mark up there our z-test statistic, our z-critical values. And again, we have 2. Another way to do this is, again, if you go ahead and do the inverse norm, so area to the left, 0, 1, that's going to end up giving you your critical values. It'll give you the negative one, but it's both positive and negative because we have 2 of them. And then you could compare these 2 values to each other, so you could see where exactly this test statistic falls at. So whether you're doing areas or comparing those 2. Okay. And so let's look at our, and actually let me go ahead and shade this in right here. There we go. That's going to be our p-value there. And so since our p-value is larger, we do not reject the null. And then that means that we reject the alternative. But since the claim is our null this time, that means we're not going to reject the claim. So there is not sufficient evidence to warrant a rejection here about the claim. And let me pause here real quick. Recall, whenever the claim is your null, you never want to use the word you support. So we're just saying warrant or rejection. So we're just being a little bit more cautious here. And then the claim here is going to be about the medications being tested and have no difference in this case. Okay. So just to finish labeling this, so that means this area over here is going to be our p-half value, but it's everything again. It's all of this going through there. And so what we were trying to say here was, is this difference close enough to 0 that they're about the same or so? So this was our line in the sand right there. And so the question is, when we converted this difference of 0.04 into a test statistic, did it fall over here where it's close enough to 0 to say, yeah, they're about the same, or whether it was over that line and say, yeah, that difference is big enough to be significant? And so we ended up with the formula here that we're going to say that it's close enough to where they're about the same. And again, so the difference is not exactly 0, but close enough, and that's what we're giving that evidence to support it. Okay, so let's go ahead and try another one here. And again, you could pause it and read through this. And so let's identify the null and alternative hypothesis. So HOHA here. We know we're talking proportions, so you could kind of see that there's percentages thrown around. And then we're comparing iPhone users, and they're comparing here African American with white non-Hispanic here. So I'm going to use subscripts of W to indicate white Americans, and then I will use the subscript of A to indicate African Americans here. And the proportion here, we're saying that it is greater, that more white Americans own iPhones. So that greater than is going to be there. So let's go ahead and denote our claim. So whenever we write in the claim, I always put that little note there. By default, the null is going to get equals. Let's get some stats and some data here. And again, I'm using my subscripts. And if you recall, p hat is what your calculator gives you. The textbook is using p prime. So I'm going to go ahead and just use p hat on this example, so you could kind of see when you look at your calculator what it's giving you. But it's most textbooks will go back and forth between this. It's not kind of a standard, half will use one, half will use the other. We're using a p prime, but just to get familiar with our TI calculator notation here. And so here we have 1343 here is the sample size. And it gives us the proportion this time. Okay, so notice the last example they gave us our X, number of successes. Now they're giving us just a proportion there. And if you recall, in order to get your proportion, it's always X over N. So if we do some algebra on this, we could go ahead and rewrite this, and we're going to find out that X is equal to N times the P hat there. And so we multiply those two, and that's going to give us a decimal. Now your calculator needs a whole number here because we're counting people. So we're always going to go ahead and round this, and we're going to call it about 134. Okay, so X must be a whole number, so just remember that. And now let's do this for the second group here, and if you want to pause it and give this a go. So 232.05, and again we multiply those two, and then we're going to end up rounding that to about 12. Okay, so let's go to our third step. We're going to graph and do the calculations here, and again we're talking differences here. Okay, and I just wanted to note here that if you had flipped this around, if you had put PA is less than PW here, these two mean exactly the same thing. So this right here and this one right here will be the same thing. Notice that P sub A is still lower than, right, on both of these cases here. It's smaller than the other one. Your values will be a little bit different as you do the test, but your final conclusion will remain the same. And that would also alter this right here when you swap it around, okay? I typically like to get information. If they talk about whatever group they talk about first, I typically name that my first group there. So here they talked about white non-Hispanics first and then African Americans. So I did it in that format there. Okay, so which group was given first in this case here? All right, we could also talk about this in terms of Z-scores. And so we're going to go ahead and shade our critical region, which is our alpha here, and it's greater than, so we have a right tail test. Okay. And that corresponds to a critical value. Okay. And so we want to get our critical value, test statistic, alpha, and p-value. Those are the key things here for our calculations. And let me just label this. So there's our alpha. And again, from our calculator, we're just going to plug that in, and that's going to go ahead and give us our test statistic and our p-value. And then our critical value is going to be 1.64 there, and that's given by inverse norm area to left 0.1 in this case. So whether you're comparing areas or you're comparing those z-scores, we're going to see that test statistic falls within that critical region here. And there we go. So it's contained within alpha this time around. That's your p-value. Okay. And again, we're talking differences here. So we're trying to find a difference between these. And we're trying to see if that's close enough to 0, right? The difference between those two. And in this case, our line in the sand is right here, and we end up beyond that. So 0.05 doesn't seem like much, but it's going to be statistically significant. It's going to be far away from 0 where we could say, yeah, it's a big enough difference. So let's go to our discussion and conclusion here. So p-value is less than alpha. So that means we reject the null, do not reject the alternative. And our alternative is a claim this time. So we're going to not reject that as well. So we're going to go ahead and say that there is sufficient evidence to support the claim. And we're allowed to support because the claim is the alternative this time. It's not as restrictive as saying specifically equals. That a larger population proportion of white cell phone owners use iPhones.